Hey, welcome to our continuation of section 5.5. In the last video, we were just kind of introducing rational functions. In this video, we're going to get into the mathematics behind them. And in the subsequent videos, we're going to focus on graphing rational functions. The first thing to talk about is domain. So when we're talking about polynomials, we didn't have to worry about domain so much at all. Polynomials are really nice. Typically, well, not typically, always, their domain is all real numbers. Any real number we plug into a polynomial, we get an output out. That even works for all the complex numbers that we can plug into polynomials. We can get an output out of it. Rational functions, unfortunately, are not that way. So quite often, the domain is not all real numbers. So if we have this rational function g of x that's pictured above, we might be curious what its domain is. And it's not all real numbers. And take a second, pause the video and think about why. All right, so if we're looking at g of x, we can think of g of x as having two parts. G of x has this top part, and it has this bottom part. Now the top, its domain is all real numbers. Because for the top, if we're looking at x cubed plus x plus 1, we can plug in anything to that and get meaningful output. Let's see. For the bottom, again, we can plug in anything and get meaningful output, but the bottom we're thinking about as division. And what's the one thing we can't do with division? We can't divide by 0. So we want to be sure we don't divide by 0. So the domain of g of x is the set, is all real numbers. We use this minus sign to indicate except. So all real numbers except the real numbers x where g of x equals 0. So that's in math. In English, it's all real numbers sorry, I wrote that wrong, not g of x, except where the bottom part equals 0. Except for where the bottom is 0. Otherwise, we'd be dividing by 0. So for this function above, the bottom part is x squared minus 1. So we'll ask where that equals 0. And that's pretty easy for us to solve right away and find that x equals plus or minus 1. So the domain is g of x, sorry, not g of x, is all real numbers minus plus or minus 1. And that's our domain. So if we plug in plus or minus 1, we're going to get division by 0, and we don't know what to make of that. If we plug in anything else, though, we'll just be looking at a real number divided by a non-zero real number, and that's fine. That gives us meaningful output. All right. So that's about it for the domain. When it comes to graphing, it'll be very important to figure out what the domain is. These are going to, the places where the domain is not defined will correspond to something called asymptotes that we'll be talking about more in the next video. To tie up a few loose ends, another thing to notice about rational functions is that the sum of two rational functions is a rational function. This is pretty important because we'll oftentimes, to better graph it, we'll end up decomposing it into a sum of different rational functions. So for example, if we have 1 over x plus 1 plus x squared over x cubed plus 2, to add these together, we just do the same thing that we do with normal addition of fractions. We find a common denominator. And in this case, the common denominator, we don't even worry about it being fully reduced. We just let it be both of these polynomials. And then we multiply the terms correspondingly, as we would with regular addition of fractions. So we have 1 times x cubed plus 2 plus x squared times x plus 1. And so again, we still have a polynomial divided by a polynomial, and we can expand to make it look even more so like that, where we get the 2x cubed plus x squared plus 2 over x to the 4th plus x cubed plus 2x plus 2. And there we have it. The same will go for multiplication, subtraction, and also division of rational functions. The multiplication is fair, it works the exact same way. And again, we know like when we multiply two polynomials, we get a polynomial. So because we're going straight across, we still get two polynomials divided by each other. So multiplication holds. Multiplication, division, and subtraction. So sometimes that's useful. And we'll see those properties come up in later problems that we do. All right, in the next set of videos, we'll focus on actually graphing these functions and understanding the graphs. All right, signing off.